This is the first question. From the equation, we get sum fx equal to 0, mean ax equal to 0. Next, we find sum moment. Sum moment of a equal to 0. And then, Ly we got 1.5 kilonewton. After that, we find sum fy equal to 0 to find y. So ay is 4.5 kilonewton. Next, we find delta and tangent. This is how we find delta and theta value. Next, we go to point A. This is equation for point A. From point A, we got FAC equal to 7.82 kilonewton and FAB 9.90 kilonewton. This is tension and compress. Next, we go to point C. Point C is same with value AC, so FCE is 7.82 kilonewton. Tension. Next, we go to point B. This is equation for point B. So FBD we got 7.07 kilonewton is compression. FBE is 2.0 kilonewton compressed. Next, at point E, we got FDE, FEG, the theta 7.82 kilonewton. This is 2 kilonewton. So this is sum Fx and FEG. We got 5.58 kilonewton tension. So sum Fy, we got FDE from here plus 5.58 multiply theta 26.56 minus 7.82 sin theta 26.56. So FDE we got 1.0 kilonewton. At point D, we must find FDF and FDG. FDF and FDG is the same value. This FDF, FDG is the same value. So FDF plus FDG equal to 5.59. This is equation 1. This is sum Fy. So we got negative FDF plus FDG equal to negative 4.47. So the answer is FDF 5.03 kilonewton compressed and FDG 0.56 kilonewton.
Okay, we'll start with point F. As you can see, the member made at point F is FG and FH. So the first thing we need to do is go to FDD. As you can see here, the force of X is 1 kilonewton. This one FG, force for FG, and this one force for HH. And this one F will 5.03 kilonewton. So the tangent equal to 25.56 degree. So this will be sum of X is equal to 0 equal to 5.03 cos theta minus FH cos theta equal to 0. So we got it for FH 5.03 kilonewton. Then this, and the type of this force is compression. It is for x-axis. The one we go through to y-axis. It must be very positive. The sum of y equal to 0. It's negative 1 minus, because the force is downward, FFG plus 2 times 5.03 sine 26.56 equal to 0. Okay, you can calculate. Force for FG is 3.54 kilonewton, and the type of force is tension. This one for Y axis. Next, we go through to point L. As you can see, members meet at point L if FJL and F for KL. So the equation will be like this. Sum of Fx equal to 0. Force for JL, cos times by 45 minus force for KL, cos 26.56 equal to 0. This is equation number 1. And then for y-axis is sum of Fy equal to 0, 1.5 minus force JL sine 45 plus force KL sine 26.56 equal to 0. And then we got negative force JL sine 45 plus force KL sine 26.56 equal to negative 1.5. This is equation number 2. So force JL cos 45 minus force KL cos 26.56 equal to 0. And then we got negative force JL sine 45 plus force KL sine 26.56 equal to negative. This one you take from equation number 2, negative 1.5. So we will get force for JL equal to 4.24 kilonewton, and the type of force is compression. And force for KL, we got 3.35 kilonewton. Type of force is tension. And then we proceed with point H. So here we can see members meet at point H is F. So we'll find force for FGH. So first we'll draw the free body diagram first. This one 4.24 kilonewton that we got from force from JL, and this one is force for GH. This one is 5.03 kilonewton. So compression is positive arrow. Sum of Fx equal to 0. 5.03 cos 26.56 minus force for GH cos 26.56 minus 4.24 cos 45 equal to 0. And then after calculate the calculator, we'll get force for GH is 1.68 kilonewton, and the type of force is tension.
Okay, so for question 2, the question is determine direction at A, F, and all the forces at B, C, D, and E. So first of all, we need to draw the free body diagram. This we will first need to draw the free body diagram of entire frame. So we draw the free body diagram. Okay, so this is our free body diagram for the entire frame. Okay, so from this entire frame, we can derive two forces at point A and F, which is here, we can see that A is a pin, while F is a roller. So, as you guys know, pin have two parts, AX and AY, while roller have one force, which is only F. Okay, so from here, we can derive the answer for AX, AY, and F using the equation of equilibrium, EOE, which is value of the moment equal to 0, value of Fx equal to 0, and value of xy equal to 0. So from here, the moment point that we will take is at point A, because point A have two direction, while point F have one direction. So it's better for us to take the moment at the point that have a lot of direction. So from here we can derive that total moment at A equal to 0. So 0 equal to F, because F is acting at y-axis, then the value we need to take is from the x-axis. So because of the direction acting down, if we rotate it, it will turn like this. This is clockwise, and this one is also acting clockwise. So, and the value we write here is anti-clockwise as positive and clockwise is negative. So because it's both of the equation is, we got clockwise, thus we need to put negative here. So F, we need to take the value from 6. So F, the length is 6, while at the 30 minus 30, the value we take is, because it's acting at y-axis, the value we need to take 1, 3, and 6, plus 6 plus 3 plus 1. So from here, we can calculate that F equal to, so here we can calculate that F is equal to 15, negative 15 kilonewton. And the value we get here is negative because the force we put here, which is it's acting downward, got the value negative. Thus it's supposed to be upward. Okay, next, we need to find the value for AS and AY. So now we have two value, which is value F and value 30. So from here, we can derive that value of X to the right is positive, equal to 0. So 0 equal to AX. And there's no other point which is at the x-axis. So thus, AX equal to 0 kilonewton. Next is Fy. The value Fy acting upward is positive, equal to 0. 0 equal to, here, the F is acting downward, so we will put it as negative 50. Wait, we will put it as negative F, and also minus 30, and also minus AY. And here we already find the value for F, so we can just put F inside it. Negative 15 minus 30 minus AY. AY equals to negative 50 minus negative 30 equal to 20 kilonewton. The value we got here is positive, thus it is true that AY is acting downward. Next, we need to draw the free body diagram of entire frame. Next, we need to do the free body diagram for this. This is what we call pulley. So for the free body diagram at pulley, free body diagram at pulley. The pulley is circle. The value is dx and dy. And we know that there's a force here, 30 kilonewton. And because it's pulley and it's have a value here, it's tied up here, thus the force is also acting there. And the value will act like this. The value is 30 kilonewton. And we know that the radius of this pulley is 1 meter. So from here, we can derive the value for dy and dx. Thus we know that we cannot use moment because there are only two forces here that we need to find. So we will use the Fy equal to 0 and Fx equal to 0. So first we will use value Fx to the right is positive, equal to 0. 0 equal to dx minus 30, because this one is moved to the left, so its value is negative. So we can find dx equals to 30 kilonewton. Thus the value is positive, so we write it's positive dx x right. Next is Fy, acting upward. To find the value at, we already find value at A, F, D. Now we need to find the value at B, E, and C. So here, we already know the value for D, so it's easier for us to find the value at B, E, and D. So here, we write free body diagram at B, E, and D. So it's a straight line with B, E, and D. So at D, we already know the value is dx equals to 30 and dy equals to 30. The value is the same, but acting to the right is positive, acting to upward is positive 30. So here, we can derive that B and E have two forces because it is connected, does it have two forces here. Thus, we will write at the free body diagram that Bx, By EX and EY. So here we need to find the value of BY, BX, EX, and EY. First, we will find the moment. Before we find the moment, we need to know the length of this to here and here to here. So, based on the free body diagram, here the value is 8, but this is 6. Thus, if it was divided by 2, 8 divided by 2 will be 4. Thus, from here, we will know that 6 divided by 2 equal to 3. Thus, the value for here is 3. And E to D, here, we know that this equal to 3. So the value here is 3 meter. Next, we will find the value at point B or E, because it's both of the point have two direction, which is BX, BY, EX, and EY. So from here, we can write that moment. We can write that moment at B equal to 0. So we have the value for EX. But we know that EX is acting at the x-axis. That's the value we need is from y-axis. But it's laid exactly at the BX. So thus, EX value is 0. EX value is 0. Yet same goes for this value. It's acting at x-axis. So the value we need is from the y-axis. And the value is 0. So here, because it's acting here, we rotate like this, so it's positive, and if we rotate like that, it will be positive. 930, 0. And here, that is EY. EY is acting here clockwise, but this one is acting there anti-counterclockwise. Thus, for the EY, we will need to write it as 3 negative EY. The value is acting at y-axis, so the value we need is x-axis. So it's 3. Next is 30. It's acting at y-axis, so the value we need is x-axis. So the value will be 3 plus 3. And it's acting counterclockwise, so it will be positive. 33 plus 3. So here, we will find the value because we know that we already know the value for EY. Thus, we do the acting upward is positive. Fy equal to 0. 0 equal to, from here, EY. Next is, first is EY. EY is negative EY. Next is negative BY. And also positive 30. Here we already know the value of EY, which is EY equal to negative 60 minus EY plus 30. Here we know the value of EY is equal to negative 60 plus 30. So the value for EY is negative 30 kilonewton. Because the value here is negative, and thus Y for BY is downward. Thus, for it to be positive value, it needs to act upward. So next, if acting to the right is positive, X equal to 0, 0 equals to BX plus EX plus 30 equal to 0, because the answer is all acting to the right. So here we know that negative 30 equal to BX plus EX. This is our first equation. Next, we'll need to write the free body diagram. We settle this one. Now it's either C or ABC, CEF or ABC. Here we already found the value for EY, BY. It's have new value. So it's easier for us to do the value at free body diagram CEF because we already know the value for F and one of the E. So the next is free body diagram at CEF. It's acting here. Have C, E, and also F. And also have a value here. Remember? It's have a value at here. Because we already removed the pulley, so it will act like that. Which is, here is 30. And the value for here is CX, CY. And because of the value, E, we already found the answer. We can work it like here. EY, EX. And we also find the value of F, which is F equal to 50 if it's acting upward. So F acting upward is 15 Newton. So now we need to know the length if we want to do the moment. So the moment here is CF to E is 4, while C, so the value of here is 1. This value is 3 because we know the radius here is 1. So 4 minus 1 is equal to 3. And E to F is 4. So we need to write the value. Here to the E is 4, while C to here is 3. And here to here is 4. Now first we need to find the moment at point either at point E or point C, because we don't know the value of EY. Thus it's better to find the moment at value C because it have two unknown force. So moment C plus it's acting counterclockwise equal to 0 plus 0 equal to force here. It will be like that, counterclockwise plus 30 with the length of 3 because it's acting at x-axis, so the value we need is y-axis. Next is EY, because EY is acting at the y-axis, so we need the value of x-axis, but the x-axis is 0, so we don't need to write it, or you can write it, it's up to you. Next is EX. EX is acting there, and the value is up there, so it's also counterclockwise, and the value here is C to the E is 4, plus EX is 4. Next is F, because the value of F is acting at the same axis of the Y. That's the value of X, and it doesn't have X value here, so the F is 0 length, so don't need to write it. So from here we can know that EX equals to ZD divided by 4. Thus we know the value of EX is equal to negative 225 kilonewton. Because it's negative, so the force is supposed to be acting to the left for it to be positive. Next, we already found this value, so now we can find the CX and CY. So the value of Fx positive acting at the right, Fx equal to 0, 0 equal to EX, it's acting there is positive, and CY plus CX is acting there, so it's positive. So that's all for the value of X axis. So EX, we know the value is negative 2.5. So next we need to find the value at the f-axis, which is acting to the left and to the right is positive. Value of x equal to 0. We know EX and CX is acting to the right, so it's positive, 0 equal to. So next we need to find the value of the f-axis x. So acting to the right is positive. Value of fx equal to 0, 0 equal to EX is acting to the right and CX is equal to the right. Well, the 30 also act to the right, so EX also plus CX plus 30. So here you can find the value of CX is equal to, put there is negative 30 minus negative 2.5. So CX equal to negative 30 minus negative 2.5. So here we know the value of CX is negative 7.5 kilonewton. Because the value is negative, so the answer is supposed to act to the left for it to be positive. Next, we already find the CF axis. Now we need to find the Y. Acting upward is positive. The value of Fy equal to 0. 0 equal to, we know 15 acting to upward is positive. We also know EY acting downward is negative. And also CY acting downward is also negative. Also, we already know the value of EY, which is here. EY is 16. Is it positive acting downward? Thus, we can put it here. 0 equals to 15 minus 16. CY. CY equals to negative 10 kilonewton. So it's positive. It's acting upward. Here. Next, we need to do the free body diagram for this part, which is A, B, and C. We already found the value of AX and AY. B, we already found one of it. And C, we already found both of the value. So next, we already diagram of FBD of ABC. We already found the A. The value for the AX is 0. So we can write it, or no, it's up to you because the value is 0. So we know that the value of AY is, the value of AY is 20 acting downward. 20. And B, we already know one of it, the value of the B, which is BY, is positive acting upward. BY is positive acting upward. Thus we don't know the value of BX. And C, we already know the value of the C. Acting to the left, we'll cause it to be positive, 7.5. And acting upward here is positive 10 kilonewton. Wait, I need to write. Okay, so here we need to find the value of bx only. So we can use the total to the right. Fx equal to 0. 0 equal to bx and minus negative 7.5. So here we know that bx equals to 7.5. Positive, turn positive, adding to the right. Question 3. The press shown is used to emboss a small C at E. Determine A, the vertical component of the force exerted on the seal. First, we draw the free body diagram. At free body diagram 2, we have 3 unknown, while free body diagram 1, we have multiple unknown. So, I could solve for free body diagram first by taking the moments about point A. So, counterclockwise sum of moment point A equal to 0. So, this is my horizontal member. FBD sine 20 multiply with lever arm of 200 sine 60 plus with FBD cosine 20 multiply with lever arm 200 cos 60. Then I have the 250 on the end, and the lever arm is the distance all the way from A to C. So I have two part here. First, 400 cos 50 plus 200 cos 60. And the last one is equal to 0. So the FPD is equal to 793.64 Newton. So we move into FPD2. Sum of Fy equal to 0. As you can see, Fe is pushing up and minus force pushing down the 793.64 cos 20 equal to 0. So Fe equal to 746 Newton, which is pushing down. So the question B asks direction at A. We use FPD1. So sum of Fx equal to 0. That means As minus 793.60 sine 20 equal to 0. And Ax equal to 271.44 Newton. So for the y-axis, we have sum of Fy equal to 0. That means Ay plus 793.64 cos 20 equal to 0. And we got Ay equal to 495.78 Newton and pushing down. But the question wants reaction at A. So this is their formula. A equal to square root Ax square plus Ay square, and A equal to square root, and enter the value that we got. So the answer is A equal to 565 Newton. Then I want to find their angle. So theta equal to shift tan Ay per X. So just enter the value that we got. And I got the angle is 61.3 degree. So here's the final answer for B.